Today we're here to talk about connected roadway modeling in Civil 3D. This is the third part in a long-standing series. I think I had the first one of these offset alignments and profiles started sometime last year. And part two on the connected alignment toolset was in June. And so we're here today to talk about now building corridor intersection models. My name is Kyle Groves. I am a senior technical specialist with ATG. I'm also an EIT. And I'm, like I said, really excited about today's topics. So let's go ahead and get through. I will let you know ahead of time. I do plan on taking the full hour of our time slot today. So hopefully you do have the time for it now. And you can always feel free to reach out to me if you do have any specific questions. So what are we doing today? Well, first off, we're going to talk about why we want to model intersections using corridors in the first place. Yeah, it's a little bit of extra work. Maybe you do or don't have the justification for it, or maybe you just want to do it because you're a completionist and a perfectionist. But there's a couple reasons too, a couple reasons not. Once we go through that, do a little bit of review on our dynamic alignments and profiles that we've covered in the first two parts of this series. And then I'm going to talk about some of my methodology for building corridors. I like to call this, or what I'm going to talk about today, and why we're going to spend so much time on the manual process as opposed to the intersection wizard, is because I'm a big believer in keeping your models lean and clean. So we're going to be talking about how we can model smarter with a plan out of our with a plan ahead of time to make sure that we only need the minimum number of model objects to get our design ready. Keeps our files smaller, keeps everything just running cleaner. So we'll talk about our object naming, and we'll talk about our baseline and our assembly management. Give a brief introduction to the intersection wizard, and then we're going to talk about two workflows. First off, we're going to talk about the proposed corridor to an existing condition intersection. And if you are strapped for time, I would ask that you stay through it for there, because really, this is everything you need to know about putting together corridors. Everything we talk about that is simply going to be expanded upon when we talk about a proposed corridor intersection. So with that, let's go ahead and keep moving forward. So you have a corridor, you have a project, but why would you want to model your intersection with a corridor? Well, there's a couple reasons to, and a couple reasons not. In favor, why would you want to mix tool sets? If you've already got a corridor modeled for your long straight sections, why would you want to have to draw feature lines, make sure that those are dynamic to any updates that might happen in your profile? You're going to have a little bit lower quality of a surface running through there. But if you have a corridor, why not continue to use your corridor? Also, if you have a requirement to have cross sections through your intersections on your project, then you're definitely going to want to be using corridors, because corridors are ideal for those cross section creation in our plan sets. Also, with your corridor, you're going to have that accurate datum surface. Now, depends on the quality of the sub-assemblies that you're using, whether or not those are going to have a true representation of your datum surface. But where you have your curb and your lanes and all the rest of that stuff, it's going to be really easy to extract that data out of your corridor and turn it into a surface object. Also, corridors are flexible. They are probably the most involved, highest skill level tool set inside Civil 3D with all their various inputs and all their various outputs. But you can be so creative when you're using corridors. I say this often in trainings, there are a million ways to draft a cat. When you're using corridors, there are that many more ways that you can go through and you can get some stuff done. I'm going to lay out some basic rules, some of the ways that I've found to make my life easier, but suffice it to say that what I'm going to tell you today is not the only way to get this done, because the corridor tool set is so flexible. However, corridors are scary, especially for new users. So one of the disadvantages of using this method is that you are going to need some practice with corridors. You're going to need to feel comfortable with what regions are, how your frequency works, what targeting is all about. So this is not a novice corridor thing, but it's a wonderful exercise for getting you to the intermediate point or getting you from intermediate to expert. Other things, pedestrian ramps are tricky. So if you're going to have that ADA curb cut out through one of your curb returns on your model here, That is not part of this workflow. We're not going to cover that today. That's feature line drafting behind the back of curb. You're probably going to be interested in using some conditional subassemblies to trigger the mountable versus the barrier curb. So doing that with corridors is tricky. Also, if you're going to be using a non-filleted or a non-circular connection to round that corner between your two roadways, this is going to be really tough because you can no longer take advantage of the connected alignment and the connected profile. You'll have to do those manually, and things get really tricky. But when we're talking about circular curb returns and you have some comfort with corridors, I think you're going to have a really fun time here today. So also, you might not need to do it because it might not be worth your time. If you don't need the cross sections or if you don't need your datum surface, then it might not be worth the effort, even if it is a fun exercise. So third part of our series, we've talked before about offset alignments and offset profiles and how powerful they can be as target objects. We've also talked about our connected alignments and their profiles and how convenient they can be for our baselines. So our offset alignments and profiles are dynamic horizontal geometry. If we change the shape of our main alignment, then our child offsets will update too. For our cross slope on our profiles, we're going to be station specific, so we can add in various cross slopes along different stations of our profile. And it's going to maintain that percentage away from our parent profile. We do also get to put in widenings. These are really handy for turn lanes, parking bays, all kinds of different stuff. But again, they're going to maintain that dynamic association to the parent alignment and or profile. For connected alignments, these are great because it's dynamic and it's a dependent data relationship whenever we're overlapping that incoming or outgoing alignment and profile. So this means that we're not just limited to a 10-foot range. We can take this connected alignment, we can run it all the way to the end of one of the alignments that it's going off of. And we'll see where that's going to come into play here a little bit later. And that's that custom station range for that overlap. We do have a fully designable interior region though. So between those two dynamic segments at the beginning and end of our connected alignment, we can put in a low spot for drainage. We can put in a high spot or whatever we need for all of that. It's completely up to us on the inside of that region. Now, we do need to keep in mind though, that this is only going to be useful for a true curve. We can't do something like an FAA runway turnout with those hard corners and those curious little chamfers. Connected alignments are true curves. So how are we going to put our model together so that we can model smarter and save ourselves some time and some headaches during the course of this process? Well, first thing we're going to do is take advantage of our object naming. Everything that we use inside this corridor, whether it's a target object or whether it's a baseline, needs to have a name that can be immediately distinguished. I'm going to recommend that you use the automatic naming template command inside. This is most Civil 3D objects. It'll say stuff like for offset alignments, what's my parent alignment? Am I on the left or the right? How far away am I? It'll fill that all in automatically. So we definitely want to use that wherever we can. When we're talking about our baselines, we're going to be really interested in understanding what's our parent object. Are we on the left side or the right side? Do we have a particular distance away? When we're looking at our intersections, we need to know what intersection am I at? What are my alignments that are intersecting, and which corner or which location of this am I in? Because we're going to be looking at a giant list of similar information, and the only way we're going to be able to figure it out without using the pick box is by reading through that list for all of that. But for our baselines, for our curb returns, we're going to be using those connected alignments for those true curves. When we're looking at our assemblies, we want to put right into the name of the assembly. Is this going to be for a full road? Is this going to be for some sort of a curb return? What side of our assembly is our lane or our curb supposed to be on? We can just look at it in a list and understand what we're up to. Also too, for our sub-assemblies, it's really important to name your sub-assembly objects, even if you're not going to be using them for targeting. I always recommend that if you are going to be using a sub-assembly to target, go ahead and type out that name in full caps lock. Helps it just zone in on this is important information. Now, that's as far as our object names are concerned. but we're also going to want to be having a plan and some standards for how these baselines are going to get put together and how our assemblies are going to get put together. So as far as our stationing is concerned, I covered this pretty heavily in the previous webinar, the one on connected alignments. Whatever is on the left side of our corridor or the right side of our corridor is determined as we follow our baseline by going forward and stationing. So with our curb returns, when we're creating all these connected alignments, if we can keep that station increase roughly counterclockwise or clockwise, doesn't matter which direction, just be consistent, it means that we can get away with only having one assembly, lane on the left side, curb on the right side with the daylight behind it. We only need one assembly for that throughout our entire corridor, which means we have far fewer objects to manage and different situations to keep straight in our head. So for our assemblies, that means that if our left side always has the daylight, we only need that one curb return. Now, I'm going to be doing the more complicated scenario of a primary crown maintained, and we'll have some interesting stuff to deal with that today. If you're in a simpler situation where both crowns are being maintained, your curb return subassemblies can go straight to targeting the center line alignments and profiles, not necessarily your offset as your edge of travel way. But we'll see more about that when we get into the software here in a bit. So with all this in play, want to talk a little bit about the intersection wizard before we get inside the software. So the intersection wizard is a fantastic tool if the only thing that you use it for is its dynamic profile locking. I have some opinions on its ability to create target objects or a corridor for you automatically. By the fact that I'm going to go through the manual process first, I think that'll give you a hint, but I'll show you at the end and you can make your own decision. But what we definitely want to use is the dynamic profile locking. Now, our primary profile, the roadway that we're not going to change, that one is okay to have a data reference. However, our secondary profile does need to live in our current drawing. Because it's going to now be dependent information, it needs to be able to update itself freely, and we can't do that through a data reference. The intersection wizard does give you an ability to create your targets automatically. So if you don't have your offset alignments and profiles, if you don't have your connected alignments for your curb returns, the wizard will do this for you. And in fact, this was the only way to get your curb returns until I believe it was 2018 when the connected alignment feature was introduced for manual creation. Now, if you did already have those, you can map those through the intersection wizard dialog. The third thing that it can do, and only if you have created or mapped those target objects, is actually create that corridor with your targeting automatically. To whatever degree you're using the intersection wizard, I have to point this out. If you have it creating objects for you, whether it's the targets or the corridor itself, you have to modify it through the intersection object. Don't go into an individual corridor's properties. Don't go into the individual alignment and profiles properties. These are all dependent data, and they must be modified at the source, which in this case is the intersection object. So with all that preamble out of the way, let's actually talk about how we're going to propose, or how we're going to model a proposed corridor to our existing conditions. First off, let's talk about our baseline. We're going to have our proposed center line as an alignment and profile. We are going to create offset alignments, which may or may not have widenings to represent our turn lanes, but this is going to represent our edge of travel way. And then we need to have an alignment that's going to represent that tie-in point with an existing surface profile. Reason why we want to have that as an alignment, not as a feature line, is because you can only have a connected alignment between two alignments. Now, with your connected alignments, in this case, we're not going to need an extreme amount of overlap, but somewhere in the 10 to 25 foot range to get started should be pretty helpful. We're also going to need 2 different assemblies for 3 overall regions. We're going to have our full road, and then we're going to have our curb return. 2 assemblies, 3 regions. Also, getting started for where exactly we're going to be tying in our initial profile for our proposed roadway here, I'm going to recommend the option of using a COGO point from alignment and profile, and I'll show you that in there. Really key to this whole workflow is understanding how to use the copy region and apply that region to a new baseline, because we're going to have the same assembly and the same targets in multiple different locations. So we don't need to go through that targeting dialog box any more than we have to. With that, I'll stop with the PowerPoint and get us into the software. Now, one real quick preamble, I did decide to create a brand new data set. I'm in the Twin Cities. I've been spending a lot of time in St. Paul, Minnesota lately, and I noticed that they've got a ton of 5-point intersections running through. So this is on the south side of the city. Mississippi's just to the south of us. We're gonna be looking at the intersection of West 7th Street, or Highway 5 as it goes past the airport, Montreal running east and west, and then Lexington here is running to the north. I pulled this out of InfoWorks Model Builder. I did some cleanup. I exported it to Civil 3D, and then here is that file ready to work on. So our first situation that we're going to be looking at is when we have an existing roadway or existing conditions that we want to tie into with our new corridor. So to get started, I need to understand where my new alignment and where my new profile are going to cross over and where they're actually going to tie in. So I have already created an alignment from that edge of travel way represented by my existing survey line work. And I'm also going to make sure that I have a surface profile cut for this alignment, and it's going to be using my existing surface as that profile. Now that I have an alignment and profile for my tie-in, alignment and profile for my edges of travel way, I can create my connected. But how am I going to turn this XYZ location of my existing into my start point for my profile? Well, we're going to run over to the Home tab, and we're going to create a point from an alignment and profile using the station offset subcommand. So the alignment and profile that I'm going to choose for this are going to be my existing tie-in. Once I choose my alignment, it's going to prompt me for a profile. This is my surface profile. And then it's going to ask me where along this alignment do I want to be? Well, now, and for the rest of this workflow, we're going to probably be starting with the apparent intersection subcommand. This is really great for talking to data that share horizontal coordinates, but don't necessarily share vertical behavior. So when I snap out of the intersection of these two alignments, it's going to give me the right spot. I'm also going to not use an offset because I want to be exactly on top of it. We do need to enter a description in here. I like to use something basic like tie. It is completely up to you what you want those to be. Go ahead and chop up my viewports. See if I can't make a little more room. I'm on a 15-inch monitor here. So we'll get some more room and come over here. This is Montreal Avenue. So somewhere on this profile, I need to tie back into my existing. In fact, if I go back by my 0 station, I can see where that roadway is. But I don't want to start at the curb. I actually have to start at the edge of travel way. So what I'm going to do is I'm going to select my profile view, and I'm going to project my new COGO point, which has accurate X, Y, and Z coordinates, into this profile view. Now, since I already went through and I know what my elevations are, I'm just going to use my object elevation settings and simply say OK. And now that I have a nice clean point on my profile view, I can simply take the first PVI of my profile and I can node snap it right onto that point. So this is how I'm going to make sure, and how I can make sure at any point during my workflow that my two profiles have been locked. Now, this COGO point is not dynamic. Don't expect it to be. If your source profile changes that you're trying to tie into, recreate the COGO point, reproject it. At this point, we are ready to now go and actually create some corridors and some regions. So I've already got these assemblies put together. They are very straightforward. I have a lane attached to my center line on each side. Behind the lane is a curb. Behind the curb is a sidewalk, and a generic link slope to surface at a 3-to-1 slope. So to create my corridor, we're going to go to the Home tab, create corridor. And this, by the way, folks, if I didn't make this clear before, this is going to be one corridor model for everything. And I'm going to call this the St. Paul 5-point intersection. And I forgot to check my regions and such. So I'll go back in to actually go to my corridor parameters. And I need to select, I need to actually create a region. Baselines first, I suppose. Now, I have mentioned time and time again, everything in a list, everything in a list. There is the green pick cube, and that can make life a little easier. But once you get into the targeting dialog, things are a little trickier, in my opinion. So I've added my baseline, to which now I can add a region. Your region is always going to be, your baseline is going to be highlighted in red. And I'm just going to create this region very simply, a couple hundred feet at most, using my full road assembly. So this is going to go through, and this is going to be targeting my edges of travelway on both sides, and I'm going to be daylighting to existing on the outside. Notice that I have, oh, I actually broke a convention here. This lane right should be in all caps. My lane left subassembly looks a lot better. But now I'm going to go through and I'm going to say, all right, left lane, what am I targeting? Well, my baseline is on Montreal, which means I need to be using my right assembly group, right lane, right assembly, right alignment. That's my alignment. Go ahead and do my left alignment. Montreal left, add, okay. Vertical, profiles, same thing. One trick I like to use when I'm in my targeting dialog is I'll use my actual target selection as a little reading guide to make sure that I'm looking at the right stuff. So this is going to help me keep my lefts and rights straight. Do my left profile, check. And that's looking pretty solid. So let's go ahead now and create our baselines for these connected alignments. So for my connected alignment, I'm going to go to the Home tab, Alignment, Create Connected. And it's important that I get my stationing always increasing correctly. So for this demo, I'm going to use standard clockwise convention. So my first alignment is going to be my existing tie-in. My second alignment is going to be my edge of travel way, and this quadrant is going to be to the outside. Now, it might not make that much sense, but as I start from the south of my screen, I'm going up, and by the time I get to the west of my screen, I'm going higher. So if we abstract that a little bit as a clock, that's how we're going to get to our clockwise rotation. Enter to confirm, and now it's time to get our connections put together. So this automatic naming template is pretty great most of the time, but our connected alignments don't really give us that much data. So my scheme here is INT for intersection, my primary alignment, in that case this is Montreal, my second alignment, which is my X tie for Elway Street, and then my quadrant. I'm also going to copy all of that to my clipboard because I'm going to use the exact same stuff over and over again. This is the southwest quadrant. Curve radius, I'll do this one as a 35-foot, 25-foot curve and a 25-foot connection overlap. That can all get changed later. You're not going to want these to be heavily labeled, so I'm going to just put this on major and minor so that I can confirm my stationing, and my connected profile is going to be just dandy. And now I have my connected alignment. I'll go ahead and I'll do the same for my other section. To continue the counterclockwise, I would now start with my edge of travel way and now choose my existing tie-in, going to the outside, paste in my intersection, primary, secondary stuff, and now I'm in the northwest quadrant. All of those other settings are good. So it really doesn't take that much time to get your connecteds in after you have that naming convention pasted onto your clipboard. I do need to now get these baselines added to my corridor so I can do my curb returns. So I'm going to choose the add baseline, and I'm going to go through and add all my baselines before I do any of my region stuff. That'll make a lot more sense when I get to that in a few minutes. So now if I were to go into my corridor properties, I would see those two baselines exist, but they don't have any regions inside them. That's fine. I do generally prefer to use the ribbon as opposed to the main corridor properties dialog box for all my corridor editing. It just makes life a little bit simpler. So now it's time to add a region, and I'm going to choose my baseline for the southwest quadrant first. And I'm not even going to worry about making my way all the way through. I'm just going to pick a region kind of on the inside of that curve, because I can adjust my region later. But if my stationing is increasing as I move up and left, that means that the left side of my assembly is going to need a curb, and the right side of my assembly is going to need a lane. Okay? Conveniently enough, I already have that assembly named and created, and I've even called it half road. What side is my curb? What side is my lane? Well, I want the lane right, curb left. Now it's going to ask me for my targeting. I'm going to skip the targeting for the moment, just so that we can kind of see how this all looks in an untargeted fashion. So yes, I'm following my baseline, but I don't have very good frequency, which means that I'm missing, I'm really aliasing and cording out that baseline curve. And my lane is not nearly far enough where I actually have a road, and it's way too long and interfering with my existing conditions. So let's go through and actually get this properly targeted now. On this one, you know, my ground targets are going to be pretty sure, my surface targets are always going to shoot for the existing. And now for my lane left, I'm going to have two targets. My first target, really the order doesn't matter, but my first target I'll just go ahead and choose as my existing tie-in. My second target is going to be my center line for this roadway, so Montreal Avenue. When you have multiple targets, you can choose if you want to go nearest or farthest in the context of a profile. We also have steepest and flattest. I'm going to run with nearest for all of these because that's going to satisfy my requirements. So now for my vertical, I need to get that same set in there, my existing travel way tie-in, and my Montreal center line proposed is going to get put in there. Now that I can say, okay, this is looking a lot better. If I want to, I can go ahead and just bring this region to the very extents of my roadway. And now I'll see that it's only as big as it needs to be to make all this stuff happen. All right, I have a baseline. On the left side of my baseline is my curb. So let's take a look at now this northwest quadrant. Well, my baseline is still going to have my curb on the left and my curb on the right, and my targeting is going to be using the exact same object. Even if I'm on the north side of this road on the westbound travel way, I'm still going to be looking for the center line over here, and I'm still going to be looking for that same alignment and profile. Now I have the option in my ribbon to use the copy region command to take all of those same settings and apply them to either a different section of the same baseline or a different section of a new baseline. So when I run that copy region command, I'm going to choose my source. And now I'm going to use the baseline subcommand to choose this other one over here in the corner. Same deal, I'll just get that fudged in initially, and I can see that this is already working. So really, because I was able to plan ahead, I was able to have an assembly that met my needs, and because I was deliberate about my stationing, I get to use that same assembly and that same targeting over and over again throughout this same area. So I'll go ahead and I'll drag these regions out to their sides, to their maximum extents, and I will bring in my main region now so that it meets up here with this other one. If I were to bring this into Object Viewer at this point, though, I would notice that these two regions, my northwest quadrant and my full road, they don't actually touch. Well, at this point, I have three options. I could create a brand new region and a brand new assembly just to represent, like, okay, I'm starting at the center line, but I'm going to the left side, or I'm going to the north, and I want to have only a half road and the curb and all the rest of that stuff. But that's an extra object. That's more targeting. That's another region to deal with. So here's my trick, and this is why I'm so in favor of the connected alignments. As long as our connected alignment is overlapping on a tangent section, then our connected alignment can run as long as it needs to. I could take this connected alignment and I could run it out to the other side of my intersection if I really wanted to. So I can just make either of these connected alignments as long as each other, or give them enough overlap so that I can stop my region at the same spot. And now I'll just endpoint snap to where my other region ended. And now I can drag my full road over so that I have a truly closed and connected corridor. So that's how we're going to go through that process. I do have one more thing to deal with, though. If I take a look, make sure I save this. Always, before you go into Object Viewer, especially if you're looking at a corridor. But if I look at this in kind of 3D view, I'll notice that I'm not actually getting to the edge and having a nice clean meetup here. And the reason why is because my targeting stations aren't finding that intersection point. So the last thing that we need to do as a cleanup is we do need to add a few manual frequency stations in to our corridor. So by picking a particular region and running the edit frequency command, we'll notice that we've got all these options. Could dial these up for any number of reasons, but I'm just going to come down for now. And this bottom part is where I can add in a custom station. So with this, you'll get your handy dandy laser level, making sure you're always perpendicular. This is another reason why I like my Kogo point that initially helped me tie in, is because Kogo points have a unique snap. It's not an endpoint, it's not anything else. It's, sorry, I didn't want those. It's a node. So now I just need to put one down exactly where I want it, which is a node snap on that Kogo point. So with one custom frequency there, and another custom frequency up here at that node snap, I now have my corridor. To make this prove out just a little bit more, what I'm also going to do is create my finish grade surface using top links and a shrink wrap outer boundary, because this surface is going to give me a really good indication as to whether or not I got all of my targeting right. So if I bring this into Object Viewer, it's going to be, or if I'm even just looking at the contours and I notice a lot of jags, it's going to be pretty obvious where I'm having issues. So it looks like, for some reason, over here, I've got a bit of a bump, and that could be related to my region transition. So I'm wondering if I got any of my targeting wrong. Let's go back and review. My main road is starting from the center line, okay. My half roads, existing Montreal, existing Montreal. So that one's fine. Existing Montreal and existing Montreal. Okay, so this all should be there. I don't think I have a jog in my profile. I don't. Make sure the baseline's correct too. Montreal. Aha, that's why. I was using the proposed ground for my main road, not my design profile. So that would be a problem. And now I can see, again, these contours are all smooth. So that was my design check. So having your surface created is going to make it really easy for you to confirm that everything is happening the way that it should be. Those contours should be relatively smooth, well, where they should be relatively smooth, in this case, across my lanes. So that's proposed to existing intersections. And technically, you could find a way to apply all of that now to the rest of this 5-point intersection. I am going to run a little bit of more PowerPoint so we can talk about that proposed corridor to proposed corridor. So with this one, now we've got some new considerations. So for our baselines, we have our proposed center line alignment and profile. This is going to be for our full road sections coming into our corridor. Our offset alignments are going to be representing our turn lanes, and really those are going to be mostly targets, not actual baselines. And then our connected alignments, these are going to be our baselines for any of those curb return or those half road sections. For our assemblies, in a double crown situation where both crowns are maintained, you're just going to need that full road and that curb return like we were talking about. This more complicated scenario, we're actually going to be using the primary crown maintained. So the intersecting road is going to dip down to meet that, that edge of travel way at the -2% or whatever cross slope from the primary. So for this, we'll need the full road and the curb return, and then we'll need our primary road to drive right through the corridor using lanes only, targeting those offset alignments and profiles. Again, we're gonna make heavy use of that copy region and apply those same parameters to a new baseline. So with that, let's hop back into the software. And I'm gonna open a new file just so that I have a couple of things done, kind of skip through the main issue. Also notice that I'm only doing a 4-point. I don't have that 5th one out here yet. So we have our offset alignments and profiles for both of these main roadways. I also have my connected alignments already created with the proper naming, and I'm still using that clockwise convention. So let's go ahead now and let's add some baselines to our corridor. I'm going to need my 7th Street alignment with its proposed profile. I already have my Montreal Street alignment, so let's also go ahead now and get in our corner sections. And I'm just pressing spacebar here to repeat my last command. All right, so those should all be there. So I should now be able to add in a region. Let's do my 7th Street West, kind of out here. I'll run my 7th Street West. This one, stationing is increasing to the southwest for this corridor. So that'll be my full road. E.g. offset alignments for 7th Avenue. Offset right, add. Offset left, add. 7th left, add. Lane right. Primary. Lane left. So we can see that's all going down it's following all those offsets, so that's really great. We'll back that out plenty for the intersection so we don't have to worry about the curb returns. Now I do need a new region representing my, that half road, or sorry, just the lanes going through there, which I don't have yet. So let's get that assembly created. Do not use AutoCAD copy, move, mirror commands on a basic, on an individual sub-assembly. However, you can use those on an entire assembly. Just make sure you go back and you rename that road. 7th lane only. Add region, view baseline, view stuff, you're the 7th lane only. Right to right, left to left. Now, I'm in a bit of a hurry today because I've got a lot of stuff I want to cover. It is going to serve you well to take a breath and just make your way through this, not like slowly, because hey, we all got to bill sometime, but just keep your mind about you, take a deep breath, read through and make sure that you know exactly what it is that you're clicking on before you go through the process of actually clicking on it. I'm also going to turn my surface off because it's going to look really goofy with all these disconnected segments. So that's my main area. I've got my full road coming in and out on both sections. I have my lane only going through on the side over here, but I also need to make sure that my profile is appropriately locked wherever it's finding all of these different things. So this is where the intersection wizard is going to come into play, so that Montreal Street running east-west here is going to actually tie in and do so dynamically. That's going to be from our home tab, intersections, create intersection. It's going to ask you, where is your stuff? I'm going to work across Montreal from right to left. My first lock point is going to be where Montreal meets the traditional edge of travel way for my primary roadway. So that's my intersection point. Then it's going to ask you to choose your main road alignment. This is going to be my edge of travel way from the other one. Your intersection name, naming template is a good thing to keep in mind here. So int dash primary alignment dash secondary alignment. I'm not going to label those up. So again, you can choose here whether you're doing the primary crown, which is what we are, or kind of that double crown, as I referenced it to earlier, all crowns maintained. The primary road is a little bit more complicated, so that's the one I wanted to cover today. Now, don't just hit the create intersection button. Confirm which one of these is your primary. In this case, it's the offset edge travel way. This checkbox and the rest of these checkbox are whether or not you either want the software to create these target objects for you, or whether or not you can map them, or if you're just going to ignore it and do everything by yourself. My general recommendation when creating intersections is to take the extra time and do it all yourself. It really doesn't take that much time to create your offset alignments and profiles. It really doesn't take that much time to create your connecteds. And once we understand some of these patterns that I was explaining with the existing to proposed situation, I think that we can figure it out, and it's really worth it to just get it done using the manual method, or at least understanding the manual method, so that if or when the magic button stops working for you, you can still finish your project in a reasonable amount of time. So by de-checking the create or map button, I'll notice that if I go to the third page, I can't do anything here because this is where it would take those target objects and automatically create that corridor for you. We'll take a look at that in a little bit. For now, I'm just going to create that intersection object. And we'll go through and we'll do the same for our intersection of our center lines. I'm going to choose my 7th Street, the northeast trending alignment for that as my primary. Next, decheck, create. Third time for our outgoing edge of travel way location, choosing the edge of travel way as the primary. Next, decheck, create. And now, if I go look at my profile for Montreal Street, this east-west one, I can see that in my profile view, when I select my profile, I actually have these little lock icons. These lock icons mean, hey, something else is controlling this data. It's now dependent on other stuff. I know that Montreal intersects 7th Street around station 1400. So if I just grab this PVI over here and I make a drastic change, now my profile for Montreal, my intersecting street, is going to pick up on all of that. And because I used the edges of travel way as additional intersection points, my crown is always going to be maintained at whatever those offset profile cross slopes were determined at. So yeah, I might need to do a little bit more design on Montreal here to the incoming and outgoing sides of my alignment, but man, I have so much data connected right now that life is pretty good. So from here, it's a simple function of taking all of your corner baselines and targeting the right stuff. So on the east half of our intersection, we're always going to be interested in looking at our center line of the secondary roadway, and we're going to be interested in the edge of travel way for our primary roadway. So I'm going to select my corridor. I'm going to add a region on this baseline. and I'm going to choose my curb left, lane right, assembly, existing. My lane is going to be looking for my Montreal center, and my offset, things are increasing to the southwest, so the left side is really the southeast of my screen. So this is going to be my west 7th left alignment, and same for the profiles. Montreal center. Okay, that looks all right. Extend it back out until I'm at sufficient overlap or at the end of my region. Now, again, we're just going to copy that region because I know my assembly. I know my targets are the same for this other one. I'm going to copy this region across to this baseline. That looks great. I do need to be concerned with completing my custom frequencies, so I'll do that over here. Run the apparent intersect because it looks like those intersection objects don't have nodes. Now, I'm only going to have time to do kind of the southeast quadrant of this full intersection here, but we can see that I'm going to run into issues in these low angle corners, right? So my initial connected alignment for this due south intersection isn't very long. And there's no way for me to make my northeast connected alignment smaller so these half roads can connect cleanly to my full road. So this is going to require me to bring my connected alignment overlap pretty far out across the connection between my other two alignments. But that's okay because everything's dynamic. So now I can take these regions so that they overlap, or rather so that they abut and they end at the same station along my primary roadway. I'll take my full road, I will drag it into the point where those all meet up. And I will do that on all sides. Save here before we get into Object Viewer. And at least on the southeast half of this intersection, I have my primary crown maintained, and I have a fully complete model running through this. Let's see if we can turn on our proposed surface to confirm that for us. And I'm not seeing any major contour violations or anything else's. So that's what we're doing here, folks. We're going to be using the intersection wizard. My recommendation is simply for the profile locking capability. And then from there, you're going to create your own custom connected alignments, manage those stations so that you only have the one assembly to use for it, and then put it all together. Now, because I said we talk about the intersection wizard and the out of the box, that's the magic button. We've just spent the last 50 minutes talking about the theory for why the magic button is supposed to work, or how the magic button is supposed to work. So I will open up a different file here that is, basically the same. Or it is the same file, just without all of that extra corridor stuff, so we can watch what happens when this does its magic, magically. So from here, I really only need my existing alignment and profile, or sorry, my center line stuff. I don't need any of this connected. Just my two center lines, and that's all that I'm supposed to need. Technically, I have that third alignment. Let me make sure that that's not interfering. Get that out of the way. All right, so 2 crossing alignments, 2 profiles. I'm going to create an intersection in their center. I'm going to choose the 7th Street as my primary profile. I'm going to continue to run the primary crown maintained. And I'm even going to let it create my offset alignments and profiles for me. So I'm just going to, before I had 16-foot lanes, for the interest of time, I'm just going to keep these at 12. But suffice it to say, each road's getting a left and a right offset. I'm also going to have it create my curb returns for me. This is going to give me the option to widen my road on either the incoming or the outgoing. So it'll basically build a turn lane in and then run the fillet connected off of it. But for this, your curb return type, I suppose you can define a chamfer if you want. The circular, though, that has the direct connection back to the connected alignment. And you can define your radii. Again, I'm just going to leave these all at the essentials. You can go through and you can define how you want your lane slopes to go away from your cross section. Those are your manually created offset profiles, as well as your curb return profile parameters too. So now that I have this second page creating or mapping those objects, it's going to ask me if I want to create a corridor. Now this is, aside from its stability issues, my main beef with the intersection wizard is all of the different types of assemblies that it has to create and all the different regions that it gives you. So now I'm going to go through, I'm just going to create this intersection. It's going to map everything up for me. And, you know, in plan view, this doesn't look so bad. I've got those small corners and they're shooting really far. I've got my wide angle corners and they're very narrow. But if I look closely, I can see that I actually have these green lines representing my feature lines of my back curb and my curb lines. Those are all right here, but they're in different spots. They're jumping around. Well, my intersection is going to create a bunch of assemblies. It'll pull them from some standards in our drawings that is customizable. Not too hard to find where all that is, but it's going to come in here and it's going to create like, okay, I've got my primary road. I've got a half lane on the left, or I've got a lane on the left, but no daylight. And on the right side, I do have the daylight, but there's no curb here. Other ones of these do have curb. So like there's a lane with a curb and a daylight. And it just creates all of this unnecessary assembly definition that, in my opinion, isn't worth putting together. The other part here that really frustrates me is that it chooses to define this region right here. This is a half road. It's starting from the center line and it's building to the north as a half road. On the downside over here, this is one of my corridor or one of my curb return started feature lines that it's shooting out over that way. I don't see the need for an additional half road based off the center line when we already know that we can make our own connected alignment as long as it needs to be, and it's going to be its own half road that can meet up with our full road later. So this one actually worked pretty well. I am, however, going to delete my intersection object. I'm going to delete my all the rest of these things because it did an okay job at putting together this non-right angle intersection, but I want to show you what happens when we do introduce that fifth or that third alignment or that fifth leg to our model here. Also turn that back on to my layout style. So it will recognize when I create my intersection at this point, since everything is collinear, I'm going to still choose my 7th Street as my primary alignment. It will recognize that I have more than 2 alignments coming in here. So it just picked up that Lexington Parkway. I'll have it create all this stuff. I'll have it create my corridor, automatically map my things for me. And I have some really weird targeting behavior going on from some of my half roads. It didn't pick up here in the north section that this half road between 7th Street and Lexington Avenue, it didn't pick up that it was supposed to stop targeting when it hit the center line of Lexington Avenue. It's going all the way to Montreal Street way down here. So the intersection wizard isn't that well configured right away for doing these 5-point intersections. It got started, but I'd still need to come in here and do some manual cleanup of my targeting. I will instead show you the version of this same file with the manually created intersection and the manually drafted model. So with this, that Lexington alignment that's running roughly to the north, I went through, I created my offset alignments and profiles. I went through and I created now the extra 2 connected alignments that go through here. But again, the principles are all still the same. I had this one put in here as a baseline. My targeting says, first, find my center line for Montreal. Then, find my edge of travel way for West 7th Street, because I want to maintain that targeting and all those setups. And then, I'm also going to be looking for my Lexington Avenue here on the side when I get through all of that. That's just my little basic region, so I can now drag this out to go meet up with my other stuff. And I can drag it out to the end here so that I can go find all that half road. And now I'm going to have all those exact same targets. I'm going to be in this northeast quadrant. I'm going to be looking for my edge of travel way, and I'm going to be looking for my center line here of Lexington Avenue. And it's not even going to find anything in Montreal, so I can just copy the region across the baseline. And adjust my region limits to meet up with almost everything. It looks like I'm actually going to run into some trouble here where we overlap these two. Which just means I need to bring all of this back farther so that I'm not in the middle of that curve. And using this manually, I was able to be thoughtful, I was able to be proactive, and I was able to get this 5 roadway intersection modeled. Last night when I was playing with these files, start to finish, this took me about an hour and a half, maybe 2 hours to go through and get all 5 of these legs of this road modeled and designed correctly without any of those other flaws. So I'm going to recommend that you use the intersection wizard simply for its profile locking, and that at the end of that, you go through and you put it all together by yourself. And the reason why is because our offset connected alignments and profiles allow for multiple levels of dynamic interaction. This saves you time and it saves you the potential for error. When we plan ahead and when we use good CAD standards and we use them consistently, it makes our corridor modeling so much smoother. We have fewer objects, we have fewer things to worry about. We're maintaining similar patterns throughout our whole thing. This keeps our models lean, which keeps our models fast. When you're going through this, it might seem complicated at first, but I really recommend just take your time and be thorough. Use your object viewer to check both your corridor and your finished grade surface for continuity and to make sure that you got all your targeting correct. Lastly, again, I want to point out here that when we have our dynamic connected models, it's going to make life easy. Yes, this took me 2 hours to model that entire 5-leg intersection, but now that it's put together, my design review is going to be very easy. I can create a surface using any of my link codes throughout my subassembly. And if I had to create a cross-section throughout this one, which I would imagine something as complicated as this would require cross-sections, it's going to be that much easier for me to create my sample lines and get a thorough picture of whatever it is that I'm looking at through this intersection. If I have to change a PVI, if I have to do that on my primary roadway, all the rest of this stuff is just going to cascade through our model. So with that, I want to thank you all for your time and attention. I know this was a very dense hour. Thanks, and have a great rest of your day. Also, feel free to reach out to me via email at kgroves@atgusa.com. I'd be happy to share this data set. And thanks again for your time, everybody.